right, good morning. Welcome back to CS 125. More of like a tepid response today. But it's Friday. You guys should be feeling good about Friday, right? Okay, so what are we gonna do today? So today we're gonna continue talking about basic imperative programming in Java. And specifically, we're gonna talk about conditional expressions. Our goal today and Wednesday, because sadly we only have one lecture next week, is to get you to the point where you can do MP0, which will be out on Monday and due a week later. All right, so we don't have any time to waste. Let's get started with a little bit of review from last time. So remember last time we pointed out that Java variables, there are 8 primitive types in Java. So variables are designed to allow us to store values. Those values can change as the program runs. That's why it's called variable. In Java, we have 8 primitive types that are the building blocks for all of the other kinds of data that we're gonna model throughout the semester. So every type of more complicated data structure that we build in Java can eventually be boiled down to combinations of these 8 primitive types. And they come into 4 categories. I've got one group of primitive types that is designed to hold integer values, values that don't have a decimal component. I have a second group that's designed to hold floating point values, and then those make up 6 of the 8 Java primitive types, and then I have one type for characters, and a final type for Boolean values. One of the things we're gonna point out right now is why are there multiple types to hold integers, to hold floating point values? Why not just one? I have actually 4 types in Java that can store an integer value. I have 2 types that can store a floating point value. Why? Why? This seems redundant. And if you've worked with other languages like Python or JavaScript, a variety of different other languages, they don't have this feature. They're just like, why do I need 4 different types to store integer values? So this is one of those places where, Java is a fun language to teach and to learn because it has both high-level features and high-level concepts. It's one of the first languages to introduce some really beautiful ideas that we're gonna talk about this semester and some really neat features. At the time Java came out, it was actually really revolutionary, some of the ideas and some of the things that Java did. But it still has this sort of underbelly where you can see some of the inner workings of the machines that are actually running our code, and this is one of them. The reason we have these different types is because in the computer's memory, these different types take up different amounts of space. And so this allows us to make trade-offs when we write our code about how much of the computer's memory we're going to use versus how many different values we're gonna be able to store. So, don't worry, I don't wanna worry too much, you guys to worry too much about this yet. One of the reasons why, people have moved on in many ways to building certain types of systems in languages like Python or JavaScript is you don't have to care about this stuff anymore. Back when computers had, I think when I was in college, my computer had like 256 megabytes of memory. Like, is that a number that even makes sense to you? Do you guys even know what a megabyte is anymore? Or there's no megabytes in the world anymore. We've just replaced them all with gigabytes. Yeah, so at the time, now this thing has, I don't know, like 8 gigabytes of memory, maybe 16, I forgot. It's just enough. And so, but, when we're programming in Java, we need to understand this a little bit. So let me show you kind of a fun example. So byte is the smallest Java type that can store an integer. And, I told you computers could do math. But can they actually do math? So let's run this example and see what happens. Can computers do math or not? This is curious. I initialized a variable called smallest of type byte on line 1, and I initialized it to 10. I declared and initialized it in a single statement, and then I modified that value using the plus equals operator to add 256 to it. And I printed it. And I have the same value. Why? Yeah. Yeah, so this is one of those places where we're seeing the inner workings of the beast. The byte type in Java can only store 256 values. So when I add 256 to it, what happened is the math wrapped around and I ended up exactly where I started. So what would happen if I add 255 to it? What do you think the result's gonna be? 9. It's weird, right? Yeah, so, and this is because of the fact that a byte can only store 256 values. So if you imagine I'm adding one at a time, you know, I get to 10, 11, 12, 13, 14, at some point I get to 256, and Java's like, oh no, I'm out of values, so what do? I just start over. Start over at 0, keep going. Okay, like I said, I don't wanna expose you to too much of this yet, but I just wanted to point this out since we're talking about the primitive types. If you're confused about this type of thing, I would encourage you always to consult the official Java documentation. Some of it, you know, if you have grown up with a more modern version of the web, I am sad to inform you that Java documentation is not the most beautiful thing on earth, but it is there and it's highly informative. So, you know, Oracle has a whole page on the Java primitive types. It'll tell you everything about them, including how many values they can store and things like this, right? What the limitations are. So let me just go back to this example and show you that if I change this to an int, now I'm gonna see that math works the way I thought. But there is a value that's big enough that if I add it to an integer, the same thing will happen. So this is an interesting thing to think about. Every variable in any programming language has a limit to how much information it can store. And, you know, this has happened to me in the past. I have written computer code, and I'm ashamed to admit this, that has suffered from bugs because of what's called wraparound. So sometimes, particularly when you're working with time, you can have a variable that starts out small and then it gets bigger and bigger and bigger and bigger, and you're like measuring the amount of, you know, microseconds that have passed since a certain point, and at some point, you run out of space. That variable runs out of precision, and now you're back close to 0. And usually, the code that you wrote has no idea what to do at that point, right? It's just super confused. Like, the amount of time that's passed since the last time this timer fired is negative. That's interesting. Okay. All right, so why do we have types in Java? What's the purpose of this feature of the programming language? This is something that you're gonna struggle with, particularly if you come from Python or you come from a background in a language that's either untyped or loosely typed. So types, first of all, types force you to be specific about how much space is required, how much precision you actually need. So for example, if I have a variable that I'm gonna use to store the number of students in this class, I probably don't need a long in Java, which I think can store like several trillion values. Maybe someday, you know, if I get what I want, I'll be teaching this course in the basketball stadium, and we'll need a long to store the enrollment. But so far, I think an int or even a short in Java, which stores a little bit less information than int, is fine. The types also allow you to correct common programming mistakes, and this is the biggest reason that we have types in Java. We'll talk about this more as the semester goes on, but when Java interprets, when it compiles and tries to run your code, being specific about what types you're using allows the compiler, which is the first step that runs when you execute Java code, it allows the compiler to find problems for you. It will say, oh, okay, so, you know, you told me that this type was, you know, you told me this variable was a particular type, and then you tried to do something to it that you're not allowed to do to a variable of that type, and this is a problem. And so this allows you to catch these types of mistakes. Okay. So at this point, what we've talked about are, you know, the basic math and storing data. We're done with that. And so we're gonna move on to one of the other 5 things that we pointed out that computers are good at, and that's simple decision making. And this is really, these next 2 topics, simple decision making and repeating things, are at the core of our ability to implement computer algorithms. Obviously, we need to store data and be able to modify variables, that's important as well, but these next 2 abilities are really kind of the key building blocks of the algorithms that you're gonna be building and implementing this semester. All right. So comparison. So at the root of a conditional expression A conditional expression in Java is a construct that allows me to tell the computer how to make a decision based on some piece of information. So based on the value of a variable, I'm gonna do either one thing or another thing. And when you guys use your computers, you may notice that, you know, certain things are happening, right? That there's some adaptive behavior. You feel like the computer, you know, is responding to, you know, you click in a particular place on the screen and it does one thing, you click somewhere else and it does something else. All of this is based on this idea. It's, you know, this is the smallest presentation of it. But once we expand that out and we have, you know, thousands of these conditional statements, we can create the type of computing experience that you guys are used to, because without them, the computer can really only do one thing every time. Okay, so this is the basis for simple decision-making within our computer programs. What we start with, in order to build conditional expressions, is comparisons. So being able to compare two things or make a decision based on the value of some variables or some constants, but usually variables. So Java has a variety of different types of comparison operators. I have equals, not equals, less than, greater than. These are math things. These are, you know, good fits for the six primitive types that we looked at that deal with numbers. So they allow me to say, is the value of a particular variable, you know, equal to something, not equal to something, bigger than the threshold, less than a threshold. So let's look at this. This expression right here in Java evaluates to a Boolean value. So when the computer runs your code, it sees something like this, and it interprets it as either true or false, and if you see, when we print it out, it's gonna print true. And if we print out, let's make this print false, so if I change my int to 101, then it's not equal to 10. I can also use other comparison operators. I have less than, also not less than 10. Is it greater than 10? It is greater than 10. Is it not equal to 10? It's not equal to 10. So these are kind of our basic building blocks for comparing variables with other variables with literals in this case. Let me point out one thing that's gonna be W for a little while. So these one-character mistakes, the small little bugs. You know, even as a mature programmer, again, I pointed this out, I would say 70% of my edits to files as I'm working on computer code are one character. It's like, I forgot this little piece here, I forgot this little piece here. This is a very common mistake, and until you get good at seeing computer code, at reading it, you will get better at this. It takes practice, like writing computer code. Reading computer code is the same way. Right now, particularly if you haven't seen a lot of Java code or a lot of computer code at all, you know, you're sort of slowly sounding things out, almost word for word. But eventually you're gonna get to the point where you can see sentences, paragraphs, you know, an entire statement, an entire block of code. But this is one of these things that you really have to start training yourself to see. Because it's a very, very small, but a very, very important difference. And it's unfortunate that certain languages have this feature. Newer languages have started to try to avoid this by using different syntax. But in Java, the top statement is an assignment. One equal sign. That means assign the value 10, in this case, to the variable A. The second statement, with two equal signs, is a comparison. That means compare A with 10 and evaluate to true if A is equal to 10 and false if not. So again, I suspect that 99% of the people in this room will face this problem at some point throughout the semester, where you'll have a piece of code, you can't figure out why it doesn't work, you're squinting at it, you know, you've been looking at it for a couple of hours, your eyes are tired, and then suddenly it's like, oh, interesting. IntelliJ will try to warn you about this. If it sees you do something like this inside a conditional expression, it'll say, oh, there's an assignment inside this conditional, you might wanna address that. So this is a good place where the IDE can help you out. All right, so again, this is, you know, let me show you what happens here. So I can do both these things as a statement. So I started out initially as in my tester variable to 10, then I print off if it's equal to 10, which is true, and then I print off the result of assigning it to 5, and you can do that. The result of an assignment statement is the result of the assignment. So in this case, I set tester to 5, and what the print is printing is the value of tester after I do that. So if I set it to 7, you'll see that it's gonna do the same thing. And then I could say tester is equal to 8, false. So yeah, so be careful with this. This is one of these really classic novice programming errors. I can also build comparisons from 2 variables. This is very common. So I can compare a variable against a literal. I can also compare a variable against another variable. So in this case, I have 2 integer variables, and I'm printing off. Now in this case, what is this going to print? False, right? Because a variable is never greater than itself. So this statement will always be false. Let's print off if it's greater than second. In this case, it's not greater than second. Let's print off if second is greater than first. That's true. Is second not equal to first? That's true. And, you know, I can use all these other operators. I can use equals. Same thing. I can include math in my comparisons. So, you know, one of the things we're doing today is we're just building up in these small pieces, and then on every slide we're making them slightly more complicated. So I can, you know, combine 2 variables together and then evaluate that against, you know, against a constant or another variable. When you do things like this, you know, so what is the statement on line 4 going to print? True. What happens when this is run? So on line 2, I have a variable called first of type int that I initialize to 10. On line 3, I have a variable called second of type int that I initialize to 20. When line 4 is executed, here's what happens. Java combines first and second, and there's all these rules about how this is done. But I'm gonna show you a shortcut in just a second that you can use to make sure that your code is clear. So the first thing that happens is first and second get added together. The result is 30. And then 30 is compared to see if it's equal to 30. The result is true. On line 5, what am I gonna do? I'm gonna take first, which is 10. I'm gonna subtract second, which is 20. I'm gonna get negative 10, and I'm gonna evaluate whether that's less than or equal to 10. And let's make this negative 12, so we get a false value. So, you know, I could put up a slide with all of the precedence rules in Java, the rules about how these more complicated statements are actually processed. It's just like you guys might have learned in algebra when you make algebraic statements, there's, you know, you do certain operations before other operations. My suggestion is to make this more clear. This is not required, particularly when you're getting started. Use parentheses the same way you can use in a mathematical expression to be clear about what happens first. So now it's very clear to somebody reading your code that first and second get added. That's the first thing that happens. It's inside the most inner parentheses, and then that's compared with 30. Same thing in the bottom. Okay. Questions about these simple comparisons before we go on? Ah, great question. So what if I try to do comparisons across types? So let's try this. Okay, interesting. What about this? Okay, so that seems to work. It's sort of interesting. What have I done here? So now I'm comparing the result of adding first and second against a literal that's gonna be interpreted by Java as a double. So if you put an integer value into your code, by default, it's interpreted by Java as an int type. If I use a floating point value, by default, it's interpreted as a double. If I wanted a float, I can use this f character, but that's not gonna change the result. So what's happening here? I don't wanna go into this in detail, But here's what Java will do for you. When you try to assign values or you try to compare things, Java will modify your types for you if it can do so without losing information. So here's what happens when the statement is evaluated. So I have an int, two ints, I add them together, but then what Java sees is that I'm comparing it against a float. So Java says, look, I have an integer. I can convert it safely to a floating point value without losing any information. I just make it 30.0, and then I compare it with 30.0, and I'm good. Let me try this a little bit of a different way. Let's try doing this. Yeah, okay. So now I have a problem. So I can take an int and I can convert it to a floating point type without losing information. If I have a floating point type, can I convert it to an int without losing information? Can I guarantee that I can do that? No, I have to throw out information to take a double and cast it, is the term, and we'll come back to this in a few lectures, cast it to an integer. And so, without you forcing it, Java will refuse to do this. Because essentially it's trying to help you. Because you could make this kind of mistake. You could say, okay, you know, I've got, in this case, I am really losing data. I have 30.1, and to compare it against 30, I would have to convert it to an int. I'm losing information. Yeah, so Java will not automatically do type conversions for primitive types if data could be lost. So I can convert from integer types to floating point types. I cannot convert from floating point types to integer types. It's a good question. Yeah. Oh, whoops. Yeah, they should be doubles. Okay, yeah. Oh, okay, so, right. So the problem here, let me come back to this example, because I've misled us. So the problem with this one is that when I'm, okay, so when I'm trying to assign the variable int, Java won't do this, because in order to assign it, I'd have to take off the decimal. If I start with doubles, this works. Why does it work? What happens when the statement is expression? Evaluate. So I have two doubles, first and second. I combine them together to get a double, and now I'm trying to do a comparison against an int. So what does Java do? It has one double, it has an int? Yeah. Exactly. So Java's smart enough to say, okay, I've got a double on one side and an int on the other. What can I do here? I can't convert the double to an int because I might lose data, but I can convert my integer literal, the 30, to a double. So that's what it does. Yeah, thanks for pointing that out. We will come back and talk about casts later. Because you can, so for example, I can do this, something like this, if I force Java. So in this case, what I've done is I've applied what's called a typecast, which is you as the programmer saying, I want you to do this. I know what I'm doing. I know this is correct. I've thought about it. And I want you to do this conversion that loses data. But yes, we will come back and talk about casts later. Okay. Other questions? These are great. Yeah. How do you do less than or equal to? Yeah. How do you do less than or equal to? Great question. Well, actually, it's right here. This guy. This laser does not make it to the screen. But I can do this. That is less than or equal to. That make sense? Greater than is the opposite. So the greater or less than is always first. The equal is afterwards. Yeah. We still don't have, yeah, so now it's angry about something else. Yes, I forgot my cast. There we go. Other questions about this? Yeah. Yeah, I didn't want to talk about this. Okay, so this is not a particularly helpful feature of Java, but you can interpret a character as an int. Don't do that, right? It's bad. It's broken. But remember, internally, all of these types are stored as numbers. So I can do something like this. Sad Java. Bad Java. Yeah. So the int is like, we can print out what first is. If you want to know the ASCII character code for first, we'll just print it out. Remember we said last time we had conventions about how we map characters to numbers? Well, here's our convention. C is 99. Now, if you want to rely on this in your program, I wouldn't, right? But yeah, internally, but this is a good time to point out, again, internally, all of this is stored as numbers in the computer's memory. That's the only thing computers know how to store, are numbers. So any other type of data we want the computer to manipulate or we want to store in the computer requires us figuring out how to take that data and convert it into a series of numbers. We talked about binary in lab last week, but it doesn't really matter. Binary is just sort of one of these implementation details of how the computers work. So don't get caught up on the fact that the computers store data in binary. Just get caught up on the fact that computers store data as numbers. Everything has to be a number. A photo of this auditorium has to be converted into a number, right? You know, again, like every complex piece of data, you know, information about how a particular baseball team is doing has to be converted into a series of numbers. Everything has to be converted into a number. Other questions? Yeah. Can you compare strings in Java? You can, and we will show you how later. Strings are actually not a primitive type in Java. They're an object, yeah. So we're not talking about them yet, but we'll get to them soon. Other questions? Yeah. Object types are capitalized, indeed, yes. We're getting a little ahead of ourselves here, but when you see a type in Java, if it's lowercase, it's a primitive type. If it's uppercase, it's an object. That's why strings are objects. That's how you can tell. All right, other questions? I like this, yeah. What can I not compare? Oh, lots of different things. Among primitive types, you know, I can't do, the rule of thumb is I can't do a comparison where Java would have to discard some data in order to do it, right, without doing a cast. Okay, so let's talk about building up more complex conditional logic. And this is not something that we're not gonna do like, and I'm not gonna ask you in this class to do super complicated examples with like 5 different, you know, conditional statements because you don't typically need them. You can write a lot of code, and in fact, your code is usually clearer when you avoid having lots of compound conditional statements. But we can take one conditional statement, the result of comparing a variable against a constant or something like that, and we can combine it with another using 2 logical operators. One is a logical AND that returns true if both statements are equal. The second one is a logical OR, which returns true if one of the statements, either of the statements, any of the statements connected by the OR are equal. So here's some examples of this. So what is line 2 going to return? On line 1, I create a variable called first of type int. I initialize it to 10. What am I gonna print on line 2? Yeah, is first both greater than 5 and less than 10? No, because it's not less than 10. It's equal to 10. What about line 3? First less than 10 and greater than 5. Still false. It's the same statement. I've just reversed the order of the 2 parts of the conditional, and so that doesn't change anything. What about line 4? True. What happens when I evaluate line 4? This is an important thing to realize. When I evaluate these statements, Java always goes from left to right. So the first thing that happens in line 4, as I say, is first greater than 10. That's false. So I continue to evaluate the rest of the expression. Is first greater than 5? It is, so I'm done. So it's true. What about line 5? What's that gonna print? False. Is first greater than 10? No, it's equal to 10. So I OR that with the literal value false. What happens if I change this last one to 9? Now what's gonna happen? Okay, I hear true, I hear false. So an OR is true if either part of it evaluates to true. So is first greater than 9? It is, it's 10. So that's true and I'm done. Once any part of an OR is true, the whole thing is automatically true. And one thing you can take advantage of when you write computer code in Java and other languages that have this feature is that Java's as lazy as possible. It won't even bother evaluating the rest of the expression. Once it finds a part of the OR that's true, it's done. It just stops. So it won't even get to the right part of that statement. Because it knows that the whole thing is true already, and so it's finished. Right, so the two rules of thumb here, I evaluate statements from left to right, and I stop soon as I find something that's and I keep going until I know the result. So when do I stop when I'm evaluating an AND? Both AND and OR have this feature where Java can get away with not evaluating the entire statement. So when do I stop when I evaluate an AND? As soon as I find a single false. Because remember, for an AND to be true, every part of it has to be true. If I find a false, I'm finished. When do I stop when I evaluate an OR? As soon as I find a true statement. So there's a nice symmetry between these. And I go left to right. As soon as I find false, I stop. The whole thing is false. If I never find false, I return the whole thing is true. With OR, go left to right. As soon as I find true, I'm done. If I never find true, the whole statement evaluates to false. Okay. So the reason that we have these comparison operators is to be used in actual decision-making logic in your code. So what I'm showing you here for the first time is a conditional statement, not a conditional expression. What we've been looking at up till now are conditional expressions. These are the building blocks of conditional statements. But this is actually a point in your code where you are telling the computer to make a decision about what code to run. And this is the classic building block for decisional logic. It's not the only one. There's some other kinds, but this is by far the most common. As a working programmer, I would say 99.9% of the conditional logic I write uses if-else statements. There's also something called switch that you can use, and we might cover, but it's, you don't need to use it. You can use if-else statements as well to do the same thing. So what am I doing here? Let's talk through this. So I create a variable called first on line 2 of type int, and I initialize it to 10. And then I have this first example of conditional logic. So this is an if-else statement, and it works from top to bottom. And you can sort of read it. On line 3, I say if first is greater than 20. And then I include something called a block. A block is this bit here between the two braces. It's our first example of a block of code. Sometimes we'll use a block of code colloquially, but it actually has a specific meaning in Java. This is a block. A block starts with a brace and ends with a brace. Not a bracket. Brackets are square. This is a brace. You have to learn the names for these things now that you're a programmer. If that statement is true, then I execute this block. Else, so if the statement is not true, I execute the block from lines 5 to 7. So what's going to happen when I run this code? What's it gonna print? It's gonna say first is not greater than 20, because first is 10. So let's set it to 21, and now we see its first is greater than 20. So one thing I want to point out right away with if-else statements, important key to understanding how they work, is that an if-else statement will never evaluate more than one block, ever. There is no way for me to, there is no value of first that will cause this to both print first is greater than 20 and first is not greater than 20. I can never get down both blocks. This is a decision. You can't be wishy-washy. You gotta go one way or the other. So whenever you look at an if-else statement, one branch is executed. Sometimes, if you don't have an else, none of them are executed. So it's at most one. But never two. And these are really the building blocks of programmatic decision making. So if something is true, do something. Otherwise, do something else. Like I said, all of the behavior that you have with your computer, this is why it does something different when you click in a particular place. This is why it does something different when you put different values in a particular form or whatever. Like, every response on your computer to input that you provide is driven by this type of thing. Millions of these statements all over the place. Obviously, things get complicated. I can build up if-else statements with multiple blocks. And again, these are evaluated from top to bottom, and we use a similar type of short-circuit logic that we use when we evaluated conditional expressions. So, I first evaluate the condition on line 1. If that's true, I execute the line of code in block 2, and I'm done. If it's not true, I check against the condition on line 3. If that is true, I execute the block on line 4, and I'm done. If not, I go to line 5. So I test one after another after another. If I find something that's true, I execute that block, and then I drop out of the if-else statement. Again, I will never execute more than one block. If your if-else statement has an else block, it serves as a catch-all for anything that doesn't match any of the statements on top. If your if-else statement has an else block, then it is always guaranteed to execute one block. Because even if none of these are true, I don't know why I continue to use this thing because it's not working. Even if none of these statements here are true, then I'm gonna end up in the block on line 8. If you don't have an if-else statement, and if you don't have an else statement, and you're not required to have an else statement, then it's possible that your if-else statement will do nothing. It'll evaluate the first condition, second condition, third condition. It's possible they're all false. And if they're all false, nothing happens, and I just keep executing the code below the block. All right, so let's look at how this works. So I've got a compound statement here where I have the first thing I'm doing is checking if comparison is greater than 5. And you'll see that I execute line 4 because it's the first thing that's true. Comparison is 10, so it's also greater than 3. So the block of code, so this second condition is also true, but it's never executed because I stop as soon as I get into the first condition that's true. What's a value for comparison that will allow me to get into that second block? So how do I avoid dropping into the first block? Okay, I'll pick something like 4. So now what's gonna happen? So I compare against 5, it's false, and now I keep going. So now I compare against 3 on line 5, and I'm done. That's the comparison that's true. I execute that block, and I'm finished. How do I get to the bottom? How do I get into the catch-all here? How do I get to the else statement? Anything below 3, right? So we'll try 2, and I get to the else statement. Now let me show you that if I don't have an else statement, there is no guarantee that anything will happen. I ran this, there's no output. Why not? Because I checked on line 3, is comparison greater than 5? Nope. I checked on line 5, is comparison greater than 3? Nope. I checked on line 7, is comparison greater than 1? Nope. There's nothing else. There's no else statement. And so, just kept going. So at most, an if-else statement will execute one block. It will always execute one block if there's an else statement. But it's also possible for it to execute 0. All right, and this is important. Only one statement runs of the if-else statement. All right, I'll skip this because I don't want to antagonize any Bears fans. Okay, if-else statements can be nested inside each other. We'll come back and, you guys are getting a lot of practice with these types of things. I just wanted you guys to see the basic idea today because it's on the quiz. I'm going to skip over this as well and finish talking about scope. So today was the first time we saw what we call block of code. This is a series of statements in your program that start with a brace and end with a brace. So, and you'll see these multiple places. You'll see them in conditional expressions, you'll see them in functions, you'll see them in classes. You'll see these braces all over the place in your code. These braces play an important role in how we choose variable names. Variables that are declared inside a block of code are not visible outside that block. However, variables that are declared outside a block are still visible inside a block that's inside of that block. I'm not sure that was the most clear way to explain that, so let me show an example. Okay, so on line 1, I initialize a variable called outside of type int of 5. And then on line 2, and this is sort of a dumb conditional statement, right? I mean, this is unnecessary, because it's always going to execute. But now I've opened up a new block, starting on line 2 and ending on line 5. And inside the block, I declared initialize a new variable called inside. Okay? Then I print outside, and then down here I try to print inside. So what's gonna happen when I run this? Okay. So what happened here? I declared a variable inside the block on line 3, and then the block ended on line 5. Once a block ends, that variable is no longer in scope, we call it. And these are rules about how variable scoping works. So once a block ends, any variables that were declared inside the block are no longer available. Now, what I want to show you is that variables declared outside the block are still available inside the block. So when I declare a new block, I inherit all the variables from outside. But when the block ends, any variables that I've created, any variable names I've initialized inside that block or declared inside that block are gone. Okay? This is one of the reasons that as you've been seeing these examples, and this is something that we're gonna really train you to do this semester, this is one of the reasons that indentation, you know, you might be wondering, like, why do we do this? Is it just pretty? Does it just look nice? Computer scientists just like to think that we're writing poetry or whatever. No. Indentation serves a really important purpose because it helps you identify blocks and therefore identify scope. So essentially, here's a rule of thumb that you can use to determine whether or not a particular variable can be accessed at a particular point in your code. And this is pretty much always true in Java. If the variable was declared to the left of the line that you're on, that's your right, okay? To the left of the line that you're on, you can access it. You can modify it, you can print its values, you can do things to it. If it was declared to the right, you can't. It's inaccessible. All right? So let's look at this. So again, same example. Outside is to my left, so I'm indented 2 spaces, outside was declared here. And so I can access outside, I could modify outside here. I could say outside plus plus. But down here on line 9, I'm trying to access inside, and inside was declared to my right. Sorry, I'm gonna get used to that. And so I cannot access inside. I can still access outside, so I can access stuff that's in the same scope that I'm in, right? But I can't access variables that were declared inside a block that's inside of the block that I'm in. Okay, so I guess I'm gonna finish a little early today, unless you guys have questions. Questions about scope, questions about blocks, yeah. No, not in Java. Maybe in other languages, but not in Java. So the question was, is there any way to declare a variable inside a block that's available outside of the block? And the answer is in Java, as far as I know, no. There are other languages where you can do this. It's usually not a good idea, right? The usual right approach is to refactor or to modify your code so that you don't have to do that, right? Other questions, yeah. No. No. The question was, do you ever not indent a block if it's small enough to put on the same line? Absolutely not. So one of the things, some of you that have programmed before, maybe in high school and APCS, one of the things you're gonna hate about this class is that we have rules about style. Yeah, I know. I know, some of you have your own ideas about where braces go and stuff like that. It doesn't matter. This is my class, and I'm in charge. And so, for the purposes of this class, this is not okay. Sorry. I know, I hear some groaning. This is not okay. Also not okay. Like, this is syntactically correct Java code, but no. Also not okay. Braces go on the same line. Braces are required for every single if statement. Also not okay, and this one really gets people. No. No ternary operators. Sorry. Once you are a mature programmer with like 10, 15 years of experience, you can come back and I will give you permission to use a ternary operator from time to time. I use them from time to time, I will admit it, right? When you're getting started, no way. They lead to unreadable code that is incredibly difficult to understand. So yes, the question was, do I have to write code the way Jeff says he wants me to, and the answer is yes, you do. All right, I have to get through my announcements now. So Monday, Labor Day, nothing goes on for the class. Wednesday, we're gonna talk about loops and start talking about algorithms. On Monday, we are gonna release MP0. It's gonna be due in a week. At this point, you should have seen enough in lecture to do 2/3 of MP0, and the rest of it we'll get to on Wednesday. On Friday, class is ruined by an unwanted interloper, this guy. So there will be no class on Friday because some guy named Obama is gonna show up and give a talk here or something like that. And so, yeah. What's that? No, he's just ruining our class and the other classes in Follinger. So I just want to say this to all of you since there's 900 people here. When I started at Buffalo about a year later, this guy showed up. And so now I'm here and it's about a year later and then he shows up again. So I'm starting to get a little concerned that Obama is stalking me. So there's a lot of people in this audience. I just want you to hear this just in case I don't show up next Monday, right? And to Obama, since he's probably watching this using the hidden cameras or whatever, like, if you want to get to know me, like, you know, just install our app and then you can find me in my office whenever you want. Okay. All right, so we won't have class on Friday. I wanna make a plea here because there's probably some people here in this audience. You guys gotta do the homework. I know there's a grace period for the next 2 weeks where we're giving you a little bit more time, but eventually these are due on the day they're assigned, okay? So here's what our numbers look like. 890 for homework 0. That's great, except there's 900 people in the class, and some of the people that did that probably moved on to 126. You can see by homework 3, which was yesterday's homework, there's like 200 of you that have not done it yet, all right? The average time it took people to do homework 3 was like 7 minutes. This is not hard stuff. It's based on lecture material, but you do need to do it, right? So get in the habit of doing this. All right, so again, no class on Monday. We have office hours today. There will be no weekend office hours this week. Do the homework, get started, and MP0 will be out on Monday. I will see you guys on Wednesday.